All right, today I am teaching an empty room again, but I do have questions that students have sent me from the CLEP College Algebra Bracket, and I'm going to work some problems. I thought it would be fun to teach an empty classroom, not have to hear anyone talking when I'm talking. It's not. Much for my little children to be here. Ooh, number 8 is a factorial question. What's got? It's got n plus 1 factorial over n factorial minus n. Now, just in case, let me ask what would that equal? But just in case, let me tell you what a factorial does. Let's say you had 8 factorial over 6 factorial 2 factorial. Well, what that means is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. And I'm going to go ahead and write all that out even though I shouldn't have. Because if you look, that 6, 5, 4, 3, 2, 1 is that 6 factorial. Then you reduce these two with what's left. What I always tell students, if you have a factorial and then you have 2 factorials below, always bring the numerator factorial down to the size of the largest denominator factorial. Because that's what you really do when you do binomial expansion all the time, is they look like that. So you need to know how to get rid of that. So say you had 10 factorial over 7 factorial 3 factorial. Well, the 10 should just go 10, 9, 8, 7 factorial, 7 factorial, and then do the 3 times 2 times 1. And then your 7 factorials divide out. 3 goes there, 3, 4, and I get 120. And that's the way you reduce factorials, when there's numbers there. Another thing to remember is 0 factorial does equal 1. I think that's so that your binomial expansion rules work and some of your other little bits of math work beyond what I know about. But honestly, 0 factorial equals 1 and 1 factorial equals 1. All right, and the one that everybody screws up on is that one, and you need it later in some classes where you will have a formula and you'll have a 0 factorial in there when you substitute in, and you've got to realize that's 1. So key little notes there about factorials. Now, if you wanted to work this one and you didn't know anything about factorials, pick a number like 5. Okay? Just make n equal 5 and see what happens. So that's going to be 6 factorial over 5 factorial minus 5. Well, if you look at that, that's 6 times 5 factorial over 5 factorial minus 5. Bing, bing. 6 minus 5, 1. And you get pretty excited there that your results to 1. And then you say, well, I want to try another one. Well, let's try 10 factorial. Let's try making n equal 10. No, I know this is not the mathematically way that I would teach it normally, but I'm going to teach it that way in just a second. Okay, and that would be 10 factorial minus 10, and you would get 11 times 10 factorial, 10 factorial minus 10, divide those out, and you get 1. So, if you were taking the test, and you look down there at number 8, you could probably just guess that it's 1. Now I'm going to show you how to work it. Notice you're going one value smaller each time. So that n plus 1 value smaller than that is n. And then the next value, of course, would be n minus 1, n minus 2, n minus 3. But we don't need that because we have done what I told you to do earlier, which is take the largest one, the one with the plus sign, and work it down to where those divide out. Then you get n plus 1 minus n is 1. And factorials, Big time you've seen them is binomial expansion. That's a good problem. I'm glad somebody asked about that one. Now, the next one that someone asked about is number 9. And the reason you ask about that is because the key's wrong. Okay. I'm not saying they would do this on the real exam, but on this practice exam that was sent to us from people that write the CLEP, you have r squared, t to the 1/2, r to the 2/3, and t to the -3/2. And you know that when you multiply those, you add the exponents. So r becomes r, and 6/3 plus, and that's 8/3. And then t becomes a -1. And then what you did was you wrote r to the 8/3 over t. And you start looking at the answers, and it's, oh no, yeah, there it is. It's E. They've corrected that problem from earlier. Last year they didn't have the right solution down there anywhere. So we're back to a good, yeah, that's E. So that's a good problem. -1, take the reciprocal. That does not mean, means multiplicative inverse is what it means. That takes care of that. All right. Well, number 10 and number 10, we taught this with summations. So I'm a little bit worried about need to ask about number 10, but then again, that was a while ago that you saw summations, and I might miss this problem too after saying that. Who knows? Because we got to talk about the ball bouncing. All right. Now, a ball is dropped from a height of h feet, so it goes h. Then it bounces, and it bounces to 2/3 of h. And then, of course, it comes back down 2/3 of h. Then it bounces 2/3 of that, which is 4/9 h. 4/9 h. Then it goes 2/3 of that, which is 8/27 h up. And don't forget, it's got to come back down 8/27 h. Now, the deal is, so notice that these happen twice. But the original fall only happens once. Now, what I would do, if I were looking at this, and it says, which of the following represents the total number of feet traveling? All right. To me, it's almost easier. I do know that it's 2/3 raised to some power, because notice, multiply that by 2/3, 2/3, 2/3, 2/3. And if I really had to look at them, I would look where there was 2/3 raised to some power. I'm thinking that I really like B and E. Just right off, I like B and E, but there's a little problem there because it doesn't have the extra 2 in it. Okay. But if you look at A, see, I'm going to miss that. If you look at A and you just put I equals 1, so you put 1 in there, you would get 4/3 h plus, then put a 2 in there. And when you put a 2 in there, you're going to get 4h times 4/9. 4h times 4/9. And if you'll notice, what I'm trying to do is see what that gives you. It gives you 4/3 h plus 16/9 h. I don't see, yeah, I do. What happened, but that would be if you multiply those together. That doesn't look good to me. And then when you put a 5 in there, you get 10 times 32 something. That just doesn't look right to me. Okay, let's look at B. Put a 1 in there, and you get 2/3 plus what you get when you put 2 in there. You put 2 in there, you get, you know what, I think I may have screwed up there. But you put a 2 in there, and you get 4/9 H. And I'm beginning to like that, because there's my 2/3 H. There's my 4/9 H. Put a 3 in there, and I get 8/27 H. Boy, that B's looking really good, but what's the problem? That's just it going what? Up. But what that does is that throws me into looking at D. Because notice how much it's like D, except when you look at it, you've got you've got the 2H, you've got the 2/3, and that's what I think. See, I think you need to multiply it by 2, because that'll look good, but it doesn't take into account you need to multiply it by 2. So let's look at D. Okay, D says you have a summation. I don't like this. I 1, 6, because you think, well, it's only going to bounce 5 times. Hang on. Yeah, ball travels between first and 6 bounce. Okay. Now, 2H, parentheses, and then 2/3 I minus 1. Okay, put a 1 in there. You get 2H. Put a 1 in there, you get 2H. Ball is dropping the height of H feet. Well, let's keep working to see, because see the first bounce, you know, it doesn't bounce the first time. But let's see what happens. Plus, put a 2 in there. You get 2H times 2/3, which is 4/3. 2/3 plus 2/3, 4/3. That looks good. Plus, and then you put a 3 in there, and you get 4/9 times 2, so you get 2H times 4/9. Bing, bing. And then I bet if you put a 3 in there, 1, 2, 3, put a 4 in there. Put a 4 in there, you're going to get 2H times 8/27. And looky here. That's perfect. My only problem is that has it going up and down on the first one. The ball is dropped from height and repeatedly bounces off the floor. After each bounce, the ball reaches a height 2/3 of what? After each bounce, the ball could go 5 feet. The ball is dropped from a height h feet and repeatedly bounces off the floor. So see how far it goes. And you know where I missed it? Total number of feet the ball travels between the first and 6th bounce. There's your first bounce right there. First bounce. So this is not part of what we need. So we do have a problem because we started off with 2H, and that 2H shouldn't be there. Well, I go back to school and I look, and somebody says, Mr. Evans, maybe you should just look at E. No, E's 1 to infinity. Can't do that one. Okay, 2/3. You don't want to do C because that's. Did I do B? I need a 2 in there. Oh, guess what? I just blew it right off. 4/3. Add those together. That's your 4/3 H. Add those together. That's your 8/9. And that's supposed to be a 2 right there. So there's your 8/9. And then there's supposed to be a 2 here. So that's. Let me just start over with, no, I'm not going to make a video that just fits that I screwed up. But if you took A, now that I realize you don't need that first H because I read the problem better, admit to your mistake, Mr. Evans. See, I love this one, except this has it going up and coming back down that first time. do number A again. I'm actually going to write it out. That way I can pay attention to what I'm doing. I equals 1 to 5, 2h, and then 2/3 I. Okay, so I put a 1 in there and I get 2h times 2/3. Plus, I put a 2 in there, I get 2h times 4/9. I put 3 in there, I get 2h times 8/27. And then all of a sudden I'm very happy because there's the 2h, 2/3, 2 of those, 2 of these, 2 of these, 2 of these. And I realized the correct answer would have been A if I would have written it down right and taken my time. That one threw me. I am so used to wanting it to be this where it drops like so. And E would actually measure what would happen from right here, and it just kept going up and bouncing forever and ever. And we did talk about infinite summations, geometric infinite, and that's what this is. This is a geometric because you're multiplying by something every time. So the E answer would be the first term over 1 minus the ratio. The first term, if you did E, would be 2/3 h. This is E. 2/3 h. This is what E would make. 1 minus 2/3, 1/3, so you get 2h. So it would travel forever and ever, and it would add up to 2h. That'd be kind of cool. That gets you more into the next level. And sorry for taking a while to work that one and screwing up and missing it the first time through, but I should have read the problem better. And it kind of makes it fun because someone that's not one of my students will watch this and go, well, that guy's just a fool. But it also gives you a chance to learn that we do make mistakes and how to look for the mistake. You know, what's wrong, what do I not feel good about? That's what I'll admit to say anyway. It's good for you to see a mistake, see somebody have to work through it. If I had to teach that again today, I'd look really good on that one, though. It's A. All right, number 12, next page. If I screw up on this one, I'm going to quit recording. Number 12. Hey, what's going on? Yeah, see, I got a student in here. He's going to sit down and listen to number 12.
Roll said you needed something to find functions or something.
Yeah, maybe. Let me see what I got here. Let me stop right there.